Okay, welcome back. In this video we are going to look at what it means to have integer coefficients and what it means to use what's called the Rational Zeros Theorem. Rational Zeros Theorem is a process that is generally used to try and find zeros of a polynomial that have integer coefficients. In order to do that, essentially what we do is we have to find what's called your P's and Q's. So essentially a polynomial with integer coefficients will have P over Q as a 0 as long as P is a factor of the constant and Q is a factor of the leading coefficient term. Now you only want to list them essentially once, but what you're doing is we're talking about polynomials where we don't just have, say, x to the fifth. Instead we've got, say, 12x to the fifth. Okay. So here in this example I have 4x squared plus 2x minus 5. So what we have to remember is that your P comes from your constants. Your Q is going to come from your coefficient of the leading term. Now with these problems you need to read your questions very carefully because some questions are only asking you to list your rational zeros. Rational meaning fraction zeros, not whole numbers. Now the way we list these is the first thing you have to do is find your P's. So again, P's comes from your constant, and we're looking at both the positive and negative. So here my constant is 5. So my P's are going to be plus or minus 1 and plus or minus 5 because those are the factors of my constant 5. Now Q is going to come from the coefficient 4. So my Q's are going to be plus or minus 1, plus or minus 2, plus or minus 4. When we talk about P over Q, we are looking at, okay, I'm going to have plus or minus 1 over plus or minus 1. So 1 over 1 is still plus or minus 1. Then I have plus or minus 1 over plus or minus 2. So that's going to be plus or minus 1/2. Then I've got 1 over 4. So plus or minus 1/4. Then I go to my 5. I have plus or minus 5 over 1, plus or minus 5 over 2, plus or minus 5 over 4. So when we're asking you to list or find all the possible rational zeros, this is what we're asking you to do. Now, we've got types of zeros. Rational zeros mean integer or fraction. Other zeros are the ones where we have radicals or complex. So you have to pay very close attention to the type of zeros that you are being asked to find. So let's take a look at here. To find both your rational and your others, you need to follow this process. The first thing you want to do is list all your possible rational zeros. Then you're going to test to see which are the actual zeros. Use your integers first unless you know for sure that that fraction is going to work. The reason I say that is because how many people really love working with fractions? Well, if you just silently raised your hand to yourself, then you're probably one of the very few. Most people despise fractions, and so therefore don't use them unless you have to. Now, once you have exhausted all of your real possible rational zeros, then that means that you probably have either a radical or a complex, which means you must use your quadratic formula or quadratic factoring ideas to finish out the problem. So with these problems, you are going to be asked to first find your rational zeros, then find any remaining zeros, and then write everything as your linear factors. So let's take a look here. I have this big long. So the first thing I need to do is find my p's and q's. So I know my p's are going to come from my constant. So plus or minus 1, plus or minus 2. I know my q's are going to come from the coefficient of my leading term, so plus or minus 1, plus or minus 3. So to find my rational zeros, I have to do p over q. So I'm going to have plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3. So the first thing that I would do is set up your synthetic. So we know we're going to have a box. Not sure what we're going to put in it yet, but we're going to look at these terms. I'm going to go 3 and -4. I have a 1, 6, and a -2. Bring down my first term as a 3 is how I'm going to get started, so I'm going to look at these. So the first thing that I would go ahead and look at is I would go ahead and look at, okay, let's use the easy one. My first term is positive, my last term is negative. So let's test -1, see what happens. Okay. Now obviously, again, we could graph this and take a look at what your terms actually are. But here, let's just go ahead and do it. So 3 times -1 is -3. Add this together, we get a -7. Times -1 is a 7. Add together gives you 8. Times -1 is a -8. Add together gives you -2. Times -1 is 2. Add together gives you 0. Because I got a 0, what this tells me right here is that I have a factor of x plus 1. It also tells me that this started as an x to the 4th, and I now have an x to the 3rd. And so here, again, I can bring down my 3. And again, I need to start a box. So in this one, and just looking at these numbers, the fact that this starts with a 3, I'm going to do something out of the box. Let's look at a 3rd and see what happens. 3 times a 3rd is going to give me 1. When I add these, I end up with -6. -6 times a 3rd is the same as 6 over 3. So this is going to end up being a -2, 8. When I add these together, I end again with a -6. -6 times a 3rd is again going to give me a -2. Sorry, this is +6. Look at that. When I add these together, I get a 0. And therefore, I have discovered that I now have x minus a 3rd. Now, the reason why I took a gamble at using my fraction is because when you look very closely at these terms, first of all, the last one is a negative, but I have an 8 and a 7 and the 3. And I know when I take a third of 3, giving me 1 sets me up pretty good for being able to get rid of this 2 on the end. Okay, now that just comes from experience. Some of you are going to find that you were doing synthetic for a really long time, and others are going to find that you can do it really quickly. Again, remember, the biggest hint I can give you is to graph the polynomial with your calculator first and use that zero function to find your possible. Okay, that's the biggest hint that I could give to try and help speed this up a little bit. Well, since this was a cube, that means this right here is now going to be an x squared. And so, since I got to the x squared part, now that means I need to solve it. So here I have 3x squared minus 6x plus 6 is equal to 0. So the first thing that I would go ahead and do is divide everything by 3. So this gives you that x squared minus 2x plus a 2 equals 0. You need to use the quadratic formula. And so when you do that, you're going to find out that you have x is equal to 1 plus or minus I. And so therefore that means we have the zeros, x minus 1 plus I and x minus 1 minus I. Now the other thing you have to keep in mind is the fact that you divided everything by 3. So when we're talking about overall answers, we are talking about the fact that we have factors, and those factors are 3 times x plus 1 times x minus a third times x minus 1 plus I times x minus 1 minus I. And this is what we were looking for, your factors. Alright, let's do one more for good measure because it's always a good idea. And so here again, I'm going to have my p's are made from the constant. So this is going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. And then I have my q, which comes from the coefficient of my leading term, which is plus or minus 1. So when we look at p over q, essentially it's going to be the same as p. Plus or minus 1, 2, 3, 4, 6, and 12. So in this instance, they happen to all be whole numbers, and the reason for that is because my coefficient here is a 1. Again, I would highly recommend that you graph so that you have some semblance of an idea on what your zeros are going to be. Okay? So here we have graphed our equation, and we have found some possible zeros. First thing we're going to go ahead and look at is 3. Again, I have 1, negative 3, negative 3, 9, negative 4, 12. Bring down that first term, see what happens. 1 times 3 is 3. Again, remember you add. This gives you a 0. Add gives you negative 3. 3 and 3 is negative 9. Add again gives me 0. So 0 add here is a negative 4. Gives me a negative 12. Add gives me a 0. That's what I wanted. So my first factor is x minus 3. Let's find the next. So again, I can open another box. I'm going to use 2. Pull this down as a 1. 2 times 1 is 2. Gives you 2. 2 and 2 is 4. Add gives you 1. 1 times 2 is 2. Add gives you 2. 2 and 2 is 4. When I add gives you 0. Again, that's what I want. So now I have x minus 2. 2 down, 3 to go. Again, I'm not quite down to a quadratic yet. At this point, I'm only at x cubed. So here, because I have 1, 2, I'm going to use a negative 2. Again, pull down that first term. This is a negative 2. When I add, gives me 0. 0. Add gives me 1. Negative 2. Adding it gives me 0. So now I have x plus 2. So this is the fun part. So here I actually now have x squared plus 1 equals 0. So I need to solve. So I get that x squared is equal to negative 1. So I get that x is equal to plus or minus the square root of negative 1. Remember, pull out the negative as an I. The square root of 1 is 1. So x is going to be plus or minus I. So this is going to give me the factors x minus I, x plus I. So if we look at it, I have 1, 2, 3, 4, 5. My degree was 5. It meant 5 factors. So therefore, my factors will be x minus 3, x minus 2, x plus 2, x minus I, x plus I. And yes, for the most part, you are being asked to write them all separately. Alright, so there you have it. Using the Rational Zero Theorem in order to find factors of your polynomials that are both rational and otherwise. So if you have any questions, please let me know. If you need any additional examples, let me know that too. And if not, I hope you enjoyed. Be sure to be creative, and I'll see you next time.